So, good day, my student. Again, we are looking at transition methods, and I'm likely to have like 5 to 7 videos on this, very short ones. So, in this video, we want to define what transition method is. Now, what are transition elements? What are transition elements? If we look at the periodic table, we discover that from hydrogen, from hydrogen to calcium, if you look at the electronic configuration of hydrogen and calcium, we will discover that these elements do not have what is called d electrons. They don't have d electrons in their electronic configuration. Now, moving from calcium to scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Are they 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. When you look at this from here to here, let me write them correctly in a row. One, we have scandium, we have titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. When you look at this, you discover that from scandium to zinc that I've written on the board, I'm not saying these are the only elements that are transition elements. But when you look at this thing, they all have what is called d electron in their electronic configuration. For instance, scandium. If you look at scandium, argon electronic configuration, then we have 3D and we have 4s. This is 21, this is 18. So this one takes 1, while this takes 2. So there are 18 electrons in argon, plus 1 making 19, plus 2 making 21, and scandium is 21 in the periodic table. All right, so looking at this, all elements that have d orbital in their electronic configuration are known as transition elements. That's condition 1. So that means to define transition element, the first condition is that element must contain d electron. The elements must contain d electron in the electronic configuration of the element. Point number 1. Like I told you in all my videos, please do everything possible, humanly possible, not to cram anything. Okay, you want to define transition elements. And I'm telling you that the first criteria is that they must possess d orbital in their electronic configuration. So if I don't want to use d electron, I will use d orbital. D orbital in their electronic configuration. Number two, in the actual definition of transition elements, this d orbital must not be completely filled. Must not be completely filled, as we find out in zinc, as we found out in chromium. If you look at the electronic configuration of chromium and zinc, okay, this one is still better because this one is not fully filled. But here, this one is fully filled here. Yes. Even copper is also fully filled. The d orbital of copper is fully filled because copper has the electronic configuration. Copper has the electronic configuration of argon, 3d10, 4s1, 11 plus 18, that is 29. 10 plus 1, 11, plus this 18, that is 29. For zinc, we have argon, then we have 3d10, we have 4s2. I will explain this one in my other video. Now, when you look at this, out of the 10 elements here, these two are also transition element according to modern definition. But in the real sense of it, since the 3d orbital is completely filled and 3d orbital here is also completely filled, it then means they are not regarded as a full member of transition elements. If you are now given this question, which of the following is a transition metal? If you are not careful, you'll be confused because in any objective question, you have to choose the most appropriate. All of them may be appropriate, but one must be most appropriate. Option A, zinc. Option B, copper. Option C, scandium. Let me use manganese. Option D, none of the above. The correct answer in this question is manganese. Because the d orbital here is not fully filled. The d orbital here is fully filled and the d orbital here is fully filled. If you have watched this video and you enjoyed this video, don't forget to follow me on Facebook. Thank you so much for watching the video.